Welcome back to topic 8.2. Let's move on to these heavy metals the industry uses, especially in mining, which is all outdoors, of course. So all of their wastewater and everything is right out there exposed, ready to leak into the natural environment. And burning fossil fuels, coal, oil, natural gas. And when it gets in the groundwater, you got a big problem because we rely on that for drinking water, and industry uses it too. So let's take a look. So we have a lot of these heavy pollutants going up into the sky, and when you have precipitation, those materials, those toxins then go back to the ground and then can infiltrate the groundwater. Here we have a big dump site with probably mine tailings, or this could be coal ash. And then you have what's called leaching, like when you make tea, right? But you're not making anything you want to drink. And then, of course, going deeper down into the groundwater, that's called percolation. Okay. And that gets into the groundwater. Cadmium, arsenic, chromium, which we'll see in a second, nickel, lead, zinc, aluminum. That can all get into, this is a well, domestic. You know, just some houses, when you don't live in a city, you need to dig a hole in the ground and put a pump in there and pump that water up. A lot of people get their water that way. We don't think about it in the city. We just connect to the city water. But a lot of our water comes from wells like that too. So we still gotta be worried about it. So yeah, the metals that were in the soil got down into the water, and then we bring it back up and then we drink it. So back in 2000, this was a really big movie. Aaron Brockovich, I think, well, they thought Julia Roberts was going to get a Oscar, but maybe she did. I can't remember. Anyway, look at this map. Here is Hinckley. Oh my gosh, there it goes again. Hinckley is up here at the top, and you may not have heard of Hinckley, but you probably heard of Barstow, because that's on the 15. That's on the way to Las Vegas. So, this very small town out there in Las Vegas, or near Barstow, has a Pacific Gas and Electric compressor station. That's what this is right here. And what that does is compresses natural gas. Natural. To put it into a pipeline. Gosh dang, pipeline. There we go. And in order to keep that pipeline clean, they wash it out with something called hexavalent chromium, or chromium 6. And what was happening is that hexavalent chromium was getting washed into tanks they were storing, and those tanks ended up leaking. And that leak eventually went into the groundwater. And hexavalent chromium, that's what's called a genotoxic carcinogen. I'm sure you know what a carcinogen is. Compound chemical that causes cancer, but genotoxic is even worse because it gets into your genes, and the damage that it causes can be passed on through a family. So this movie came out in 2000, is based on a case in the 90s where they successfully sued Pacific Gas and Electric for the people, and they compensated the people of Hinckley. Put out a lot of money to alleviate their contaminated wastewater, compensate them. there was a lot of cancers and stillbirths and miscarriages that were going on, and they successfully argued in court that it was because of this hexavalent chromium. But typically it's very difficult to prove absolutely that one chemical caused a human disease, because us humans, we are exposed to so many different things. It is difficult to pin it down, but the consensus scientifically is that hexavalent chromium does cause cancer and these reproductive issues. Look in the stomach of this poor bird that died, all this plastic litter. So when it gets into the aquatic ecosystem, being washed off the streets, it can create intestinal blockages. So you see happening right there. Intestinal. That bird can't, even if it does eat regular food, it can't get through, it can't digest it, it's going to die. And then, of course, they can also just choke, so choking hazards. And, of course, toxic substances can be in those plastic, that litter, that material that gets into the water. In terms of sediment, we're also disrupting the land, so more sediment gets in there, so that creates less infiltration of light. Less light infiltration, which can affect primary producers. That means things that photosynthesize, and visual predators, so primary producers, aka plants, right? And that sediments also settle, disrupting the habitats. So let's take a look. 2 habitats. Here we got a good one. We have high light levels. Everything is good. That light is reaching the bottom. It can support plants. That keeps a lot of oxygen and not a whole lot of resedimentation. This is basically, the sediment coming back up, creating a cloudier environment. And then you have nitrogen. You have nutrients recycling successfully. Now, when you have low light, you're not going to have, look, those plants aren't there anymore. There's not enough light for them. So they're not going to be growing. That means there's going to be less oxygen. You're also going to have, because giant plants, more of that sediment is going to be resuspended, making it even darker. And you're not going to get the nutrient recycling. Okay, you can get those nutrients is trapped down there. In the low light, low oxygen, we know is not good for fish, oysters, shrimp, clams, whatever you're trying to raise. The fishing industry, tourism industry, people don't want to go and look at a bunch of nasty water like that. Okay. All right. So we talked earlier, mercury is released when coal is burned. Also some from volcanoes. We can't forget about that. So an elemental mercury enters the environment. Now this is pretty dastardly crazy. Bacteria in the water convert that mercury into something called methyl mercury, which is even more toxic. Methyl mercury has come up many times. So as we see that, and there's mercury coming out of mines here. Let's not forget about that. So the bacteria in the water convert it to methyl mercury, and that goes into the krill, plankton and krill, and you see just up the food chain. Okay, and this is called biomagnification in the food chain. And biomagnification is just that as you go up the food chain, the top consumers, the higher trophic levels, have a higher concentration. So let's write that. Where is my... higher trophic levels? That means you're eating high up on the food chain. Higher trophic levels equals more toxins. And down here, lower on the food chain, fewer toxins. So that's why it's sometimes better to eat lower on the food chain than the top, you know, the fancy albacore tuna, halibut. Tuna. Oh yeah, albacores are even higher. Yeah, so regular tuna, which you have to be careful of, but you just see this increase in concentration. And EPA advises people to really limit that their consumption of these high food chain animals. Okay, it tastes great, but I forget. Let's see. Yeah, what was behind that? I don't think anything. Ethyl. Yeah, mercury. I think that was an accident. All right, so this is the case. Well, the most famous case of mercury poisoning came out of this is in Japan, and this is the 1950s. You had this case of Minamata Bay, right here. A chemical factory now. Chiso now makes LCD displays. They make the liquid that goes into the LCD. So if you have a Sony, Vizio, Hisense, TCL, if you have one of those TVs, Samsung TV, you have liquid crystal from this Chiso factory in Japan. What was happening? They were just dumping a lot of methyl mercury into the bay, just right into the bay. Normally, people in Japan would have a 4 parts per million concentration in their body. The people in Minamata Bay had around 200 parts per million. So they had a lot of poisoning. And basically it's a neurotoxin. So you have trouble moving your hand. Like this person here, they can't move their hand properly because their nerves, their brain's not functioning. It just causes a diffuse set of very disabling problems. So I believe, about 2,000 people died directly from it, and about 70,000 sickened. But it was a huge controversy. You can see up here on the top corner, that's a protester, at the factory, because as you may know, in Japanese culture, it's heavily based on food from the ocean. It's very seafood based. So a lot of their food was coming right from this Minamata Bay that was just soaked. That was just with this high concentration of methyl mercury. Settlements occurred, and I don't know today if they think it's remediated. I'll try to find out about that. So this is about human impacts on the environment. One thing that we love to do as humans is build roads through things, and I love driving. I love riding my bike through roads, on roads, and in roads. Roads in the forest. But it can be really damaging having roads. I'm sure you've heard about the mountain lion population in Southern California, how stressed it's under because there's just too many freeways all over the place and they can't move around successfully. But if you look, you have something called interior and edge habitat. So in interior habitat, you don't have a lot of exposure to what we see these edges are. And over here, you see bears, all these butterflies, owls. Once you start to fragment the habitat, you really don't have a whole lot of interior habitat left. So over here, we have no bears, right? Where are they? They're gone. There's not enough habitat. You've shrunk that habitat. There's not enough area. Also, no owls, right? Owls have disappeared. Meanwhile, edge species increase. So we see the birds, there's 2 over here. Oh, now there's 4. So what I want you to be able to do is, look at a diagram like this if it's on the exam. see how interior habitat compares to edge habitat, and make this observation. By increasing the edges, you give an advantage to those edge species, and you disadvantage species that rely on that interior compact, having a certain amount of space and area to survive and to hunt and to live. See deer increase, got more deer. They're really good with edges. So this is the main thing that we're doing, besides taking everything over, is we're reducing the amount of interior habitats. All right, that's 8.2.